8.2 gets a little harder because now we're going to get quadratic proportions, meaning I'm going to have an x squared term. Normally that means that I have two answers that work, but we'll see. Okay, so here I'm going to cross multiply. So 8 times 10 would be 80. 5x times x is now 5 times x to the second power. That means an x got multiplied by itself. Then I want to isolate this x squared term, just like if it were 5 times x. So I would divide away the 5. 80 divided by 5 is 16 equals x squared. Then the opposite of squaring something is square rooting something. And so that would make that just x now. But what happens is I get two answers. I always get positive and negative, the square root of 16, which is 4. Because right here, I can put in 4 squared and get 16. I can also put in a negative 4, square it, and get positive 16. So now my answer does, or my question to you is, do both of them work? If I had 8 over 5 times 4, that would be 8 over 20 equals 4 over 10. Does positive 4 work? Yes. If I put in negative 4, that would be 8 over 5 times negative 4 is negative 20. And then I would put in a negative 4 here. Negative 4 over 10. Does that work? Yes, because this whole fraction's a negative and this equals the same negative, which are really negative 2/5 or 2/5, right? As long as both sides equal each other, you're good. So you get two solutions there. All right, number 2. We're going to cross multiply. So we have 5 times the quantity x plus 3 equals x times x plus 7. Distribute, you get 5x plus 15 equals x squared plus 7x. Now this time I have an x squared term, I have two x terms I'm going to put together, and a constant, whereas this problem only had a single term that had an x in it. So I could isolate it and then square root, but this one is not going to allow me to do that. So what I want to do is leave my x squared where it's at, and I'm going to move everything to that same side so that it's set equal to 0. So move that. I'm also going to subtract the 15 over. So now I have 0. Nothing on this side equals x squared. 7x minus 5x is positive 2x minus 15. This is called standard form of a quadratic. ax squared plus bx plus c. It has to equal 0. Now I'm asking myself what foiled to make this. Because if I look, there's nothing I can divide out. There's no greatest common factor because this number is a 1, and I can't take an x out of all terms. I could try to add the 15 over, but then I'm stuck again because I have two terms that have an x in them, and they're not like terms. So factoring is the only answer here. So I know x times x, when I FOIL, gets x squared. Then I want to jump to the last term. It has to multiply to make c. Okay, so multiply to make negative 15, and then add, I'm going to say add in parentheses because it could be subtracting, to make b. So what two numbers multiply to make negative 15 that will add or subtract to make 2? Well, I should be thinking 5 and 3. And I need one to be a positive, one to be a negative, because I want to multiply to get negative 15. If I do a 5 for my positive and a 3 for my negative, think about what that's going to make for your outers and your inners. That would be negative 3x plus 5x. That's going to make that middle term 2x. So that would get x squared plus 2x minus 15. But now how do you use that to get the answers? Well, once you factor, it's super simple. You're going to set each factor equal to 0 and solve. So this says, what number plus 5 would make 0? That would be just the opposite, would be negative 5. What number minus 3 would make 0? Just going to add 3, so you'd get the opposite of 3. And both of those should work. I'm not going to check them. I'll tell you that they do. Okay, let's try another one. This time it has a negative, so just make it go with the 6. So I get negative 6 times x minus 6 equals x times x minus 1. Distribute, I get negative 6x plus 36 equals x squared minus 1x, or x. Okay, again, I see x squared and I see x terms. I want to get this to where it equals 0, and I want to always keep this squared term positive, so I'm going to leave it where it's at. I'm going to add 6x to its like term on the other side and subtract the 36. And you could even rearrange it to where, okay, now I'm going to say x squared, 6 minus 1 would be positive 5x minus 36. I can set it to equal 0 on the right side. It's however you want to do it. Kind of like how that looks better. I know that I can't take anything out. I know that I can't solve this. I'm going to have to factor it. And factoring kind of reminds me of a tree, and it branches off. We're branching this off so that we have pieces that are linear to solve. We got to think of what multiplies to make a negative 36. That already tells me I need one of each sign. So that could be 1 and 36, or 2 and 18, or 3 and 12, or 4 and 9, or 6 and 6, all the options. It's got to be a 4 and a 9 because I want them to be 5 numbers apart because I'm really going to be subtracting. And I want more positive, so I put the 9 here and the 4 here. So picture foiling that out. You would get x squared, negative 4x plus 9x, which is 5x. 9 times negative 4 is negative 36. Now to get the solutions, take each piece, set it equal to 0, and solve. So you should see where it's just going to be the opposite sign. Because I'm subtracting 9, I'm adding 4, so negative 9 and 4 are both my solutions.